Hi everybody, welcome to Lecture 8. In this lecture, we want to finish EIGRP process by illustrating EIGRP route calculation phase. Therefore, after this lesson, I expect you to describe EIGRP choosing routes process. Let's start our today's mission. When two routers become neighbors and inform each other about the topology table by sending full updates, now it's the time to calculate the metrics and choose the best route and put it in the routing table. EIGRP formula is this, and it seems complicated. As you could see, this formula based on the bandwidth, load, delay, extended attributes, and reliability. Let's define some of these words. Bandwidth is the bandwidth that you configure on your interfaces, and the bandwidth which involved in this formula is 10 power 7 divided by least bandwidth. Least bandwidth means the minimum bandwidth of a path from your links. For example, if you have two paths from this router to this network, for this path, if you have two links or three links to reach network X, the least bandwidth selected between this link, and this link. And the minimum bandwidth of these links put in the formula. Therefore, we have 10 power 7 divided by least bandwidth. And bandwidth involved in the formula in kilobits per second. The second parameter is load. The third parameter is delay. Delay implies in tens of microseconds, and the delay is the cumulative delay, not the least delay like bandwidth. Cumulative delay means that if we have 10 here, we have 15 here, and we have, for example, 30 here, the cumulative delay would be 10 plus 15 plus 30, which would be 45 and 55. So bandwidth is least bandwidth and delay is cumulative delay. Extended attributes are used in wide calculations or wide metrics. For now, there are two extended attributes, jitter and energy, and finally reliability. As you could see, the default K values for K2, K4, K5, and K6 are 0. Therefore, in this formula, these parameters would be 0 because it's an multiply operation. This would be 0, this would be 0, this would be 0, and this would be 0. And K1 and K3 would involve in the formula calculation. And this formula will convert to 10 power 7 if you want to extend it, least bandwidth plus cumulative delay, multiple 256. This is the EIGRP metric formula in default situation. If we show bandwidth with this equation, 10 power 7 divided by least bandwidth multiply 256, and delay here, cumulative delay multiply 256, the formula would be bandwidth plus delay. These are the different ways of showing the formula. There is no any difference between them. Therefore, you could mention the formula with this or with this, with the explanation of bandwidth and delay like this. Although this formula looks very complicated, but in operation, EIGRP route calculation process is very lighter than OSPF algorithm and use less RAM and CPU of your router. Let me say something before finishing this slide. K values from K1 to K6 are changeable, and I will tell you the command in the right time. But Cisco strongly recommends that do not change these values. If you change one of these values, remember that these are the parameters for becoming neighbors. So you have to change them on the other side too. So remember two things. First, do not change these values, and if you decide to change these values, do it on the both sides. Now let's see an example and review some EIGRP keywords. As you could see in this scenario, router A, for example, has two paths to reach this router. Let's name these routers B and C. and this one D. Now, router A has two paths A and path B to reach router D. These information gained from EIGRP update messages. Now it's the time for calculating the metrics. Now router A calculate the metric for path A. In this path, as you could see, this is the least bandwidth between these two bandwidths. So router A put it in the formula. And the delays are accumulated. 2000 plus 2000 would be 4000. And the formula is complete now, and the result is, as you could see, this. And path B, again the least bandwidth and the cumulative delay, and the result is this. Between these two routes, clearly this one is the best. So router A put this path in its routing table. This metric now is called feasible distance. Feasible distance is the best metric in the perspective of the calculating router. Now let's assume that this router has a neighbor router and connect to it via this link. Now, when router A advertised this feasible distance to this router, this distance renamed and it is called reported distance, or RD for short, and this is FD for short. Okay, the feasible distance is the metric that is calculated by the router, and when router report it or advertise it to the other router, this distance would be reported distance or advertised distance, RD or AD. Now, when an EIGRP router put this route in the router, this route named successor route. I wrote it here before. Successor route is the best route that would place in the routing table. But unlike the other routing protocols, EIGRP does not wipe this calculation out and store it in the topology table with the name of feasible successor route. But this route must meet a condition to be feasible. We call it feasibility condition. This feasibility condition is that if a route wants to be a feasible successor route, the reported distance of this route must be smaller than the feasible distance. So if the reported distance of this route is smaller than the feasible distance of this route, it could be put in the topology table with the name of feasible successor route. But you may ask me that when the router uses this feasible successor route, router uses feasible successor route when the successor route is failed. In this example, if this route is failed, the router instantly situates the feasible successor route in the routing table. Therefore, EIGRP convergence time is very quicker than any other routing protocol. The other thing about EIGRP is that if the successor route is failed and there is no feasible successor route, or with any reasons it is not in the topology table, what would EIGRP do? Unlike OSPF, which stands back and recalculate the routes and try to find the other route, which is rerunning the SPF algorithm and put the pressure on the CPU and the RAM of the router, EIGRP uses a query and response method. When the successor route is failed and there is no any other feasible successor routes, EIGRP router tries to query the neighbors and ask them, hey neighbor, could you help me to reach this network or not? And this query will propagate to the network. If this router knows about it, will answer it, and otherwise it will ask the other neighbor routers, and this query will propagate to the whole of the network. And if there is an available route, one of these routers will inform this router, and this router put it in the routing table. The whole process, which we talked about it in these lectures, from the neighbor lecture to topology exchange lecture and this lecture, which was the EIGRP process, is called dual diffusing update algorithm. EIGRP algorithm is called dual, and Cisco insists that to call it dual FSM, finite state machine, diffusing update algorithm, finite state machine. So keep in your mind that EIGRP process is called dual, and in Cisco's perspective it is dual FSM, finite state machine. Now it's summary time. In this lecture, we review EIGRP metric calculation formula in different forms, and you see some of them. And finally, we saw some keywords of EIGRP, which was feasible distance, reported distance or advertised distance, successor route and feasible successor route. And we saw the query and response method for finding the lost route. I hope this lecture helped you to improve your knowledge, and see you in the next lecture.